We're going to talk about MySQL and NoSQL, how they exist together, where they kind of came from, talk about some of the differences between the different solutions out there, give you a better idea of what's out there and what problems they've tried to solve, and how MySQL can do a better job of trying to fix those problems internally. So first we want to thank our sponsors. So you've seen them all day today, but I don't know if everyone knows who I am, but I work for Percona. I work for MySQL and I work for Sun. I have over about 15 years of database experience, and I'm fun at parties, as you'll find out tonight. So what does Percona do? You might ask, hopefully by now you know what Percona does, but we do this, we take this, and we do this. So that's about as easy as I can make it. So we're about making things go fast, but we do other things too. So let's start by talking about where the MySQL ecosystem is today, and kind of how we got there. So right now, probably the biggest problem that is facing most of the MySQL deployments out there is lots of data. How many people have over 100 gigs of data in their database? Okay, 500 gigs, a few. Terabytes, that's a few more. So, big data, explosive data is a problem that is, plaguing a lot of companies right now. And so how to deal with this explosive growth and how to effectively scale is a really big deal, and it's a really big challenge. MySQL's focus up until this point has been really to scale up, okay? So if you look at most of the enhancements that have come down the pike over the past 3-4 years, it's all been about how to get more out of your single box, okay? Used to be that NoDB only scaled to 4 cores. Now NoDB can scale up to 32 cores. Used to be that you had issues with, large buffer pools. Now that, problems are being pushed out a little further. So, things are moving along and there are enhancements being made. Solid state disks, these are something that have opened up a whole new, type of performance tuning because, we never developed a lot of the database software to deal with disk that fast. So as the hardware has gotten better, we've had to make adjustments, okay? But one of the things that we haven't focused on that much is the need for more servers, okay? And I don't know if anybody's a Trekkie fan here, but the trouble with tribbles, the industry has really been about scaling out, especially recently, but this is a cyclical event. So if you go back into the mid-90s, you'll find Oracle was all about the big hardware, and then they started to get into Oracle Parallel Server, and then they started to get in rack, and then the industry buzzword back then was scale out, and we'll just scale onto commodity Linux boxes. And so they kind of went that route. So with the industry now, they're back to that scale out model. So you start to see the rise of cloud computing, specifically EC2, and you start to see that, hey, servers are cheap to add. We can throw up commodity boxes by the dozens. We can throw up EC2 instances by the dozen, and we can just grow as our capacity demands. It's really a good model because you really just pay for what you need. Okay? Today, companies now have thousands of servers. You look at like the Google data center, the Facebook data centers, any of these big companies have thousands of servers that are out there, and they rely on this scale out approach to get their throughput. But in addition to just scaling out, we have these data retention things. Now, there's companies like Infobright who talked earlier today about, analytics on really big data, but, there's this need to just analyze just tons and tons of data and store it for seemingly forever. Does anybody, out there, I know I have this problem, have a problem where, their management says, we can't lose any data, we never want to get rid of it, we want to keep it forever? Nobody has that problem, right? Because there's value in it somewhere down the line, somebody's going to want it, right? So what we're seeing is the retention rates are actually outpacing the hardware growth. And so, because we now need, these, hundreds of terabytes or petabytes of data stored, the hardware isn't keeping up with it. So even, solid state disks, you're looking at solid state disks of, 512 gigs. That's really small when you have to look at petabytes of data. The other thing that has happened is Developers want easy, okay? SQL is powerful, but it is complex for a lot of developers, okay? So, they think that, hey, SQL is overly complex. I don't want to worry about it. The optimizer does crazy, stupid things. It's just ugly, okay? So there's, an overhead for developers to really become SQL ninjas. And, it takes them, a while to learn SQL, whereas they're really experts in whether it be Ruby or PHP or JavaScript. So what they've done is they've turned to ORMs. ORMs suck, okay? It's the square peg in a round hole type of scenario, okay? How many people like ORMs? Is anybody out there? Nobody's going to admit it, are they? All right, oh, look, we got one person who likes ORMs. Great. There's nothing wrong with ORMs, but they're generally used really inappropriately and badly. Does everybody know what an ORM is? Yeah? One? Oh, okay. Object relational mapping? Okay, so active record. Anybody run Ruby here? Rails? Okay. We got some PHP guys? Okay, more PHP guys than Rails guys right now. All right. So basically what an ORM is, it allows you to map your objects, and it generates a SQL for you. If you're Java guys, it's Hibernate. Have any Java guys out there? Okay, great. So Hibernate. You guys don't have problems with Hibernate, do you? No? Okay. Didn't think so. But the problems with ORM is they do really stupid things. Okay, like, hey, I'm just going to throw this extra table join in there for no apparent reason, and it ruins your query plan. Or I'm going to make everything a left join just because I think it should be. It just does horrible, horrible things, but developers love it because they don't need to think. The other thing that is really, an industry norm now is the fact that there are just tons of fast-moving changes coming at you. All right? So everything comes in, and you think you got it nailed, and then all of a sudden it just changes again. We don't deal with end-user requirement changes at all, do we? I mean, does anybody out there actually have the perfect balance where the end user comes and tells them what they want the first time, and it's right? No? Okay, I didn't think so. Same thing in the database, right? There are changes that have to happen, whether you have to add columns, whether you have to, change data types, you have to add an index. Things happen. Craigslist, I watched a presentation that they gave about MongoDB, and they talked about how, hey, in their archive database, it took a month to add a column. That's a long time, right? So there are a lot of other people out there who, run alters that take days and weeks. And so we've developed tools to kind of mitigate that, but it's still a huge problem. So MySQL has really missed on a lot of these opportunities, right? So those were the droids he was looking for. So we have, things that should be in the stock MySQL release, like online table adds or alters, scaling out, okay? Flexible data types. Those are just a few things. But, these are things that we haven't done well as a MySQL community in adopting. And because of that, other people have taken it and said, you know what, we can do this a little differently, all right? So, and this is nothing new. People find better ways of doing things, or what they think is better. It depends on the solution. But, the RDBMSs of old didn't keep up with the demand. So you had a lot of these companies saying, you know what, I have a really good idea, and let's see how far we can take it. Okay? And a lot of these companies, like it's, the Facebook type of thing, they developed it. They developed Cassandra, and then they released it, and then they altered it and did their own thing. But, they did it to solve specific problems that the database just couldn't handle. So the idea is eliminate the pain points and eliminate the unneeded fluff. Okay? You might actually hear that from some of the Drizzle stuff, too. They claim, hey, that's one of their things is, there's a lot of fluff in MySQL, so we wanted to rip it all out. But there's a trade-off, right? So, you have to live without some things that are standard in relational databases. So NoSQL is a term that covers like everything. It's like saying, you're a man or you're a woman. There's a lot of different types of men and women. But you have key value stores, you have column stores, you have document stores, you have all these different types of database or NoSQL solutions. But what are some of the core things that they all try and fit into? Well, going back to the list of things that MySQL has done appropriately, one of the things that they do is they try and have a more developer-centric interface. Because developers don't want to learn SQL, hey, there's ways that they can natively access the database without having to learn SQL. For instance, MongoDB has a nice little JavaScript command line interface, and every web guy, even the guy who will code for food, loves that. Because he can go in and he can do his JavaScript ninja foo and get out what he needs. Okay? It also allows things to be returned in formats that can be easily consumed by web services or by web pages. So things like JSON or a serialized string or things like that can all be easily stored and retrieved and searched. And that is a really powerful thing. And you shouldn't underestimate how powerful that is. Because the ability to just return the JSON string to like a web page and not have to go through a driver, not have to parse, not have to put things into different variables, that can add a lot of overhead. The other thing that they've looked at is how to scale out better. Okay? And some of them use MapReduce. Okay? Others use sharding. Okay? Others use some form of replication. But the idea is, we know this isn't going to work on one box. We know that this is too complex to work on one box, so we're going to have it work on many boxes. Okay? The other thing is it's easy to change because, like I said, everyone knows that users will get up in arms and demand beer. Changes. So, but we know that they're going to demand things on the fly. So the ability to add a column or to change what's stored and to analyze it without having to take tons and tons of downtime is going to be critical in the next 5 to 10 years. It's critical now. But there's also things that go into these solutions that are designed to solve those really specific problems, whether it's gridfs in Mongo or lists and sets in Redis or super columns in Cassandra. They add features for whatever they were developed for to specifically solve that problem. So when you look at the NoSQL solutions that are out there, each one of them has something that's just a little different that offers something a little unique. So where are we now? There's a lot of talk about should it be SQL, should it be NoSQL, and they tend to fight like cats and dogs sometimes. But there really is a lot of FUD around it. Okay, the developers that I know, especially in the Rails community, not so much in the PHP. I guess it's just those weird Rails guys, huh? They love to hate on MySQL because I think they latch on to a lot of the newer technologies because they are so compelling. Okay, but a NoSQL solution doesn't mean that you don't have to think about your design. All right. So you still have to think about how tables are going to be stored, or collections, or whatever you want to call them. You still need to think about how that data is going to be stored and retrieved. And you have to plan for it, okay? You can't just randomly add nodes, okay? That's another really common misconception is all these NoSQL solutions is I'll just add 5 new boxes. Well, there's shard rebalancing that has to occur potentially. There's other potential issues with network latencies and transmitting traffic between more nodes. So there's a whole complex underbelly here that most people just don't see. It also doesn't mean you can get sloppy with your code. Okay, because it is so easy to access these objects natively in many of the languages, people get really sloppy with their code and do some really ugly things that cause performance issues. And this isn't going to replace a relational database fully. There's just features that don't exist in these solutions. And the last one is really bad code is bad code. If you design bad code, it's going to run crappy in MySQL. If you rewrite it and it's good code, it will run good. And so what I found is a lot of places that I've went and evaluated, or did a bake-off with MySQL and NoSQL solution, you'll see that a lot of the code is just bad in MySQL, and they rewrite it, and it's the rewrite that actually fixed most of the problems and not necessarily the MySQL solution. So it can be as complex, the NoSQL solutions, as you want it to be, or as uncomplex. It's really like SQL, okay? But you have to look at what you're going to store and how it's going to be used, okay? Are you going to correlate this data with other data in the system? How much duplication of data is acceptable? When we're talking about petabytes of data, having duplicated data, that might add petabytes more, okay? And that might be a deal breaker for some people. But on the MySQL side, there's a lot of hate on, oh, NoSQL. NoSQL stinks because of fill in the blank. I mean, there's several videos out there. But you have to realize that not all NoSQL solutions are made the same. Yeah, some of them don't have transactions, but neither did MyISAM. So, for, years and years, you had companies who built websites that were really robust and worked really, really well on MyISAM. And now, maybe they don't need transactions, right? But, people also hate on durability. Durability, the NoSQL databases, if you pull out the plug, it's going to crash and all your data is going to go away. Well, there are a lot of advances where they've been trying to prevent that. As with any new technology, as users demand new features, they start to get slowly added. And there's also trade-offs where you can add, in most of the NoSQL cases, better durability for a decrease in performance. And another thing, everybody thinks that NoSQL immediately means eventual consistency, which is not the case. All right. So remember that MySQL started as another technology that was an outside the database thing, and now look where it's evolved. So in another few years, you don't know where some of these solutions may end up, and they might have some of the features that people consider as deal breakers now. But while this has been going on, so while the NoSQL solutions have really started to crop up and become more popular, MySQL crowd hasn't been sitting idle and just sitting on their hands. Okay. Now, everybody here familiar with MySQL Cluster? Okay. Not very many people, a few. Okay, MySQL Cluster is like the original NoSQL solution, or one of the originals. It is a key value store at its heart. Okay, NDB, the NDB storage engine, is basically a distributed key value store that allows you to partition your data across multiple nodes. Sounds just like a lot of these other NoSQL solutions that are out there, because it is. They just put a SQL layer on top of it. Okay, so we can actually learn a lot from how the NDB in the MySQL cluster was built and developed and maintained over the years. All right. One of the things that we have found, and this is where you get a big performance gain, is hey, in the NDB cluster, a lot of times to get optimal performance, we have to bypass the SQL layer completely and write directly to the underlying APIs. Well, that kind of sounds like NoSQL, right? I mean, when you talk about whether it's MongoDB or Redis, you're accessing the data directly. You're not actually accessing it through a SQL layer. Same thing here. So this is from a couple different sources here, but parsing the SQL is actually an expensive operation. All right. So if you look at where time is spent, a lot of time is spent in the parse. So Dina actually directed or developed handler sockets. Anybody here heard of handler sockets? Okay, a few. All right. Handler sockets is a way to actually access InnoDB data via a NoSQL type solution. Okay? So instead of actually having to write SQL to access your InnoDB tables, you can go directly against the underlying tables and pull the data out. All right? I can show an example if we don't run out of time, but basically the idea is it's like a key value store. You say, I want to access this index, and here's the value that I want, and it will return your data for you. And it's incredibly fast. Yoshinori did a blog when he released this. He worked for Dina. And they hit 750,000 transactions a second using this, which is a lot on commodity hardware. Okay, so and it was 7 times faster than the stock MySQL. Now I have not redone those benchmarks. The most that I could get on my little box at home was about 3 times the performance. But it's still a substantial increase in performance when you're looking at it compared to your stock SQL solution. Vadim did this benchmark where he actually looked at some of the differences between using like Fusion IO and RAID 10, but you could see even he, when he did this, he's getting 600,000 selects a second, which is just phenomenal amount of reads per second. So Oracle kind of looked at this, and Sun has had a long history with Memcache D, and they've said, well, you know what? There could be some value in accessing this data outside of, the SQL interface. So in the most recent, dev builds, they've released a Memcache D interface for InnoDB. So you can actually access a table directly with libmemcache D. So how many people here run Memcache D? A lot of people, yeah. So you could actually, instead of using Memcache D as a target, use InnoDB as a target, and then you'd have persistent Memcache. That's the idea anyways. There's still a lot of bugs with it. I did try and benchmark it to get some numbers for this, but it was just so horribly, it was not ready to benchmark. Let's put it that way. I'll say it politely. But the idea is, this could be a really powerful tool. And one of the great things about this is they promised the ability, or, well, Kelvin's son promised me the ability at a conference, so I'm going to hold him to it, that you can actually eventually use the distributed hash capabilities of Memcache D, which you can't in the initial development release. So that would mean that you could have this data go to multiple shards and have it automatically shard your data, which would be really cool. So the question that I know probably a lot of you out there are going to ask, should I look at this stuff? Or maybe you've got that oddball guy in the corner who keeps on saying, we need to replace MySQL with fill in the blank. Or maybe you are that oddball guy who keeps on telling everyone else that you need to replace it. So the answer really is, it depends on your application, okay? It really does. What you need to look at is you need to ask yourself, what kind of application are you running, and what are your needs are? Do you need to run transactions? Okay. Some people do, some people don't. Some people, it's life and death. I mean, you ask that to a financial guy, and he's going to laugh at you because there's no way that he would ever even consider anything that has risk of losing data or doesn't have transactions. Can you risk data loss? How much data loss is acceptable? Okay. What are your performance requirements? All right. Some NoSQL solutions, surprisingly, are less performant than MySQL solutions. So you have to ask, what are your performance requirements? What are you trying to get out of this? Okay. What level of risk is acceptable? Some of these solutions are wonderful solutions, but there aren't companies behind them. There are community efforts, which for some people is life and death. Some people, hey, they're all for it. And it just depends on your level of risk. And what are the costs involved? Scaling out is great, but there's a cost to scaling out. And it's a cost that most people don't consider, network bandwidth, server, capacity, the rack space, I mean, there's quite a bit of, concern with, the scale out model. And then there's also development time, okay? This is one of the things that I've, seen, several times is, developers can get sometimes a lot more done quickly with some of the NoSQL solutions just because they don't have to worry about the SQL interface that they don't know. Other times, if they're really good at SQL or they're going to use some ORM, they can do it in equal time, but sometimes it's not that great. So, general MySQL considerations, why you'd choose MySQL over some of the other solutions, durability, okay? Data loss, or lack thereof. If you have third-party applications, a lot of third-party applications don't support some of the NoSQL solutions yet. Do you need to integrate with other RDBMSs? Or do you have that skill set in-house? Do you need transactions? Do you need joins? What kind of workload do you do? For the NoSQL side, maybe SQL's overkill for you. So would a simple key value store work for you? Okay. Would a document, data store work for you? Do you have data that can stay in a consistent format, or does it change all the time? I mean, those are pretty big, requirements. Are you CPU bound? Do you do really complex computational tasks that might require a MapReduce? How much data are you talking about? Okay. Do you have rapid changes to the infrastructure? Okay. Well, one of the big things that I know, I mean, does anybody here not care about performance? Okay, I didn't think so. So you have to realize that, when benchmarks get published, benchmarks are very, generally a generic case or very, specific to that company. So, either you run something that is so specific it's irrelevant to everyone else, or you run something so generic it's irrelevant to someone else. So, benchmarks. But, the performance can vary wildly, okay? Like schema and object design in a, like a MongoDB. You might have to duplicate data, or you might have to create join collections, or you might have to store, extra columns that you wouldn't, or fields that you wouldn't have to store generally. And, that can bloat your, schema design there. Your data types, okay? one of the funny things was I was working with a client who actually just took some data and dumped it into MongoDB and said, hey, great. Well, the problem is they didn't actually choose the correct data types. They just took the document and converted it, and then they all came in as character fields. So, well, why doesn't my sums work? Why doesn't my aggregate functions work? Well, you didn't think about, converting those to the actual correct data types. What kind of indexes do you need or do you not want? Okay, are you going to use an ORM? What sort of driver performance? And this is another. I harped on space a little bit, but this is a really key one because space also equates to memory as well as disk space, right? So when you have to load these data sets into memory to actually process them, if the data is bigger, it takes more memory, which means you're going to have to buy more boxes, which kind of exacerbates the problem. I did a quick test for a client who we were actually looking at MongoDB, and we took an XML and we parsed that XML out. We turned it to JSON. We put the JSON in Mongo and we put the JSON in NoDB in a normalized table, and the difference was 5 times. So that's a pretty big difference. Okay. So just realize that hey, space is a huge deal. You have to benchmark these before you even decide to put these in production. Some people will run things into production without actually testing. In fact, one of my colleagues who works with us now put in some stuff called Waffle Grid that we developed a while ago. He put it into production because he was kind of cavalier about that stuff. It was kind of interesting, but see here and there. So verify these solutions in production, okay, or in development or staging before you move to production. All right, don't just leap in, okay. But don't be trapped by legacy problems either. When you go to rewrite these in test, make sure that you write them for the solution that you're going to build. So, rewrite things that don't make sense, and use benchmarks that are specific to you and not generic ones. So let's talk about some of the NoSQL options. Look at the little cute monkey. So MongoDB guys are here. They've sponsored. They gave us mugs. Everybody get their Mongo mug? Yeah. All right. So MongoDB has a great JSON interface, especially if you're going to have any sort of AJAX that's going to be consuming JSON. Having that and having it return in that format, you can't underestimate how beneficial that is. Having MapReduce capabilities, that's really beneficial for a lot of people. The durability has gotten much better. It does have built-in sharding and supports replication. You trade some of it off where you don't have transactions, you don't have native joins. Your data footprint can be larger. So there are some trade-offs there, right? So you need to make sure that if you're going to jump into this, that you realize, hey, we might have problems if we need to join collections. And if we decide not to join collections, we just decide to store it all in one object, well, that means that one object's going to get really big, okay? And so, that's a trade-off. Redis. Redis has become incredibly popular, and a lot of people have thought about using this and do use it as a Memcache D replacement because it can do persistent, key value stores, which is kind of cool. It actually has the capability. It used to be forced that everything has to be in memory, okay? But now you can actually use virtual memory or, basically disk space. It does support clustering and it does support replication. It's super fast and does have complex data types like lists. Some of the bad things about it, though, are if you do use some of the advanced features like virtual memory, it actually disables things like durability. So you probably want to look at the documentation and figure out whether you want to use some of the more advanced features. So there is some chance of data loss, and there's no native joins, and it's key access only. So if you have any sort of complex where clauses or have to go against the secondary index, there are none. So if you use Memcache D and you want to store things that make sense in Memcache D, but you want them persistent, Redis is a really good place to look at. Anybody using Cassandra? One person. What are you using it for? Okay. A couple years ago, everyone was like, oh, we're going to move to Cassandra. You know, I remember having a conversation with one of the Rackspace, guru guys, and he was like, "Oh, we're thinking about making Cassandra like our stock database of choice." And I know Twitter was all Cassandra-y, and everybody was, "Oh, Cassandra, Cassandra, Cassandra," and now she's the jilted kind of stepchild, so not a lot of people are actually investing right now in Cassandra, which is funny. But it does have a pretty decent model. It does have auto sharding of data, replication, allows you to do parallel processing. The super column features are pretty cool. Do you use the super column features? No? Okay. But it is eventually consistent, which means that if you write something, you might not get it back if you lose a node. The documentation isn't nearly as deep as some of the other NoSQL solutions. And really, speed is more of a byproduct of adding additional nodes than it is of the internals. It is very network chatty as well, and it has durability issues. Hadoop. People use Hadoop here? A few people. Great. Obviously, if you've got petabytes of data, Hadoop is probably something you want to look at. Extreme parallelism, and you can do all kinds of great, mappy, reducey things. But it can be complex, and you need time. This isn't something that is going to just produce something instantly, so you have to set your expectations. If you're going to go over a petabyte of data, it's going to take you a while, unless you're going to have thousands and thousands of nodes. Does anybody here run thousands of database nodes? Okay. Harrison from Facebook, I guess, isn't in here. He might be like, yeah. Couch. The Couch guys in here? No. Okay. I'm not going to say anything bad about them. You don't have to report back. You don't have to tweet that I'm dissing on the Couch guys. But similar to Mongo, it's a document store, which is, what's kind of cool about the Couch design is it's resistant to corruption. So if you yank the cable and you plug it back in, you should be back to where you were. Say, hey. It's versioned, so it does use MVCC, which is kind of interesting. It has JavaScript capabilities, does a REST interface, has the whole MapReduce thing, but it doesn't do sharding, and it can be slower than some of the other solutions out there. Now, there are ways to do all of those things that those NoSQL solutions do in MySQL. Okay, whether it's a storage engine, okay, whether it's something like shard query, which allows you to shard your queries across multiple shards. You can actually use an XML, or store XML in a blob, and you can use the XPath queries to give you kind of a virtual column. MariaDB just released their new dynamic columns, I think they call them, where you can dynamically add columns to a table, and it stores it internally in a blob field. You can do sharding, you can do cluster, but these are complex technologies, and a lot of the NoSQL solutions have really just tried to make it easy. So they've tried to eliminate the need to, hey, I need to go find another storage engine, I need to figure out the pros and cons, I need to implement it, I need to implement sharding, I need to, figure out some hack or workaround. Certainly there are many ways to get that same result in MySQL, it's just that the level of work seems to be a lot higher. So that's all I got for you. I think we're done with time anyways. So thank you. And I guess I can take some questions. What time is it? Well, I think that most of them try to build in sharding into it, so it's actually built in easy to use. So instead of having to go through and figure out what shard key, what node it's going to be on, there's software already there that takes care of that. Certainly you can write something like in MySQL proxy to handle that, or some other technology, but obviously it requires some work. So that is one of those things that if you can fix that, and I think like shard query, they've tried to do a little bit with the shard query stuff to, fix how easy it is to, go against multiple nodes. But until it's actually built into, you know, like a MySQL component that's installed everywhere, I think there's going to be some overhead and there's going to be some learning curve. Whereas if you drop in, let's say, a Mongo, hey, you got sharding in there. I mean, it's basically like a proxy solution anyways, but it's, you know, it's part of the core product.
Back to your comment about regulars. I saw the same presentation that you saw, and my take from it was that the reason why I took them off is that they're kind of famous. How do you maintain the schema in like MongoDB?
How do you maintain the schema?
Well, if I keep on making changes to my schema,
Right.
and I keep on storing it in, then we store it in the object store. So do we have any kind of like mass mapper use tools or some sort of tools to actually fix the schema to keep it consistent?
No, so you're saying like if you went in and changed like a column name, like so if for instance, for, you know, this revision of your data had you know, this column meant this and now it means something else. Is that what you kind of mean?
Yeah, you add a column or something.
I am not aware of any. Okay.
So basically your mapper use queries that your application keeps growing become much more complex than
It's possible, yeah. Yeah, if you start adding columns, I mean, the idea is if you add columns or add additional fields into your, you know, your JSON object, they should be different. So if you go and aggregate them, they should aggregate correctly, because if you do a sum of some new field, it's going to ignore all the records that don't have that field, right? But if you go ahead and, you know, say like, okay, if the type is this, then use this column, and if it's this, use this other column, and then if it's this, use this other column, then that's complex, and that's going to also cause issues in, you know, MySQL depending on how you architect it. And so it really gets down to, you know, how you end up architecting your system and what kind of changes that you're going to make. All right. Oh. A little bit. I didn't include it in here because I haven't worked a ton with it. I think I made a mention on one slide as a bullet point, but it's just something that I haven't worked with at all. So I didn't include it as something that, you know, people are pounding on. Oh, did I? Oh, I'm sorry. Want me to go back to the Tokyo Cabinet slide? Oh, sorry, I must have been too clicky. Tokyo Cabinet. I like Tokyo Cabinet, actually. Anybody here use Tokyo Cabinet? Does anybody here know what Tokyo Cabinet is? Wow, lots of people. All right. So Tokyo Cabinet is a really cool library that you can actually set up as a daemon if you want, but really it's built to be like an embedded database or an embedded key value solution. And they have multiple table types, so you can actually set up different types of tables within it, whether it's a btrieve table or simple key value store, or there's a column or a fixed length table type. So depending on, like, you know, what sort of solution you're looking for, you know, there's some really interesting features within Tokyo Cabinet. I did a series of blog posts last year on MySQL Performance blog on Tokyo Cabinet. There's a ton of information on this here. But some of the problems that you run into are there is no sharding, but you can use the Memcache D interface if you use the key value store table type. So you can actually use the distributed Memcache D logarithms within libmemcache D in order to shard if you wanted to do that. But there are some durability and consistency concerns. So when it doesn't do an fsync as often as it should, and so sometimes data gets really backed up, and if you pull the plug, you can lose a lot of data. So you have to be careful with that. And you can force it to actually do the write, but if you force it to do the write, your transactional throughput goes down the crapper. Which is the case with a lot of the NoSQL solutions. Like if you look at anything that's persisting to disk, the more that you persist to disk, or the more that you want to force that durability, you trade off for performance. Okay, great.